Alright, so we're talking about scatterplots and interpreting graphs, and we're gonna start with, scatterplots first. So, on here, on scatterplots, I mean, a scatterplot is just a bunch of points, that's all it is, just a bunch of points on there, and they're all standard, you know what they are. And when, it's gonna go into a lot of things right here, it's gonna go into positive correlation, negative correlation, whether it's strong, whether it's weak, those kind of things. We've talked about all this before. What was that one thing on the calculator that we found when we did something on there, when we put in a bunch of points that told us whether it was strong or weak or negative or positive? What was that variable we looked for? One thing that I said, we went over last week, and I said, you've gotta know how to do this, because when you get your calculators back before you test, you're gonna have to reset them, because they're gonna be reset. You're gonna have to do this to your calculator before this is ever gonna come up on your, calculations. You really need to know how to do this on that calculator. You may remember what it was we had to do over here. And so you really need to remember this. We were talking about lines of best fit and regression lines. You know, remember what it was? And we put things into stat, and we put them into edit, and we did our L1s and L2s, and we went through and did that, and then what did we do after that? We did stat, calculate, and then we did a regression, depending on what we're supposed to do, a linear or a quadratic, and then we went down to, the exponential regression, which was 0. We did 3 of those. Then we did stack calc, and we talked about number 4, which was the line, 5 was the quadratic, the parabola, and we had one more that we went through, which was the exponential regression right here. So what was that one thing that when we did it, if I just do, I don't even know what my numbers are in that, oops, that's not what I want. That's helpful. We need to do linear regression. So I'll be done. Stack calc 4. And we just ran through this, and there was something that comes up, and what was it? What was the key part to that? It told us whether it was a good fit or not. Right there on the screen, the R was one of the things that we were looking at. If you don't have that in your notes, you need to put it. I stressed this last week. You gotta remember how to get this. If your calculator doesn't have that on there, how do you get it on there? How are you going to turn this on so you'll be able to look at it on your calculator when you're taking your ESC? How do we turn that on? What do we do to turn it on? You got to remember how to do it. Where do we go over here? We have to turn the diagnostics on. Where do we go? You really need to be paying attention, not tracing all over your paper and drawing. You can have that calculator looking at it. If you don't like sitting here with me, go on down the hall, go to secretary. Maybe you'll talk to them, maybe you'll pay attention to me. You gotta remember where we went on the diagnostics on? There's 2 or 3 different ways we can do it, but I told you one way. Not math. One way. Mode. Go to the mode. And what did you have to make sure was on? That diagnostic. You have to make sure that's on. So on your calculator right now, if it's not on, put it on. Go to stat, or not stat, so go to mode, and make sure that your diagnostics are on. Because if they're not, it's not going to give you that R. And you don't want to miss 2 or 3 questions just because of something simple like this. Because I promise you, you will have questions where you need to see that R on it. And if you go to calculate your regression, whichever one it is, you're going to need to see what R is. You're going to need to see whether it's a good fit or not. Now, what are the values? What are the possible values R could be? From +1 to -1. So a +1 was a perfect positive correlation, a -1 was a perfect negative correlation. So going back to this, is this positive, negative, or no correlation? If we drew a line that tried to go through as many points as possible, it'd be positive. Let me see if I can straight line. As the hours of studying increase, the test variable, what happens to your test scores? Well, presumably, the more you study, the better you're going to score, right? So as one increases, the other decreases. When one increases, the other increases. Two positives to two negatives. So that's why they call it a positive correlation. So just like on a negative correlation, well, they drew their line in here. On a negative correlation, they've drawn a line in here, but look, as one increases, as the hours that you watch TV goes up, what is this will happen to your test score? It's going to go down. So as this one increases, this one decreases, which is a negative correlation. And that's, even if they didn't have that line, just like they've got right here, you can still see it's kind of a positive. It's going up, or it's going down, or, well, then they get into the strong or weak. And I told you, remember, just like Charles said, a plus one is a perfect positive, a minus one is a perfect negative. What of those values on that R indicated something strong? I told you last week, this is a strong one. If it gets anything below this, it's a weak correlation. You remember that decimal I told you? A 0.5 is definitely weak. Anything below 0.7 is going to be weak. So anything below 0.7 or negative 0.7, above negative 0.7 is going to be a weak. Anything in the 0.9 is going to be a strong correlation. Okay? And you notice here, see how these look like they're more in a straight line, whether it's positive or negative, than these do? These are kind of almost a perfect straight line. That's why they're called a strong correlation. These, if I drew a line in here, it's not going to go, it might hit one or 2 points, right? It's not going to hit all of them. They're going to be kind of scattered all around. So that's what they're calling their line or curve of best fit. That's what we call our regression line. And then they're going to put those things in. They're going to put their points in there. If you were given a scatter plot and told to find the regression line, like they found the line up here, these are just a bunch of points that they put in. Like that's 140, 160, 270, 380. Just a bunch of points that you put in your L1 and your L2, and you can just stat count 4. That's how they came up with that line. But so they did this one right here, the number of players. Now think about this logically. If you have a bunch of people going to play miniature golf, putt-putt. If I have 2 people playing putt-putt versus 10 people, which one's going to cost more? 10 people. So the more people I have, the more it costs, right? That's a positive correlation, which is why that's going up that way. Now this point right here, that point 0.04, that's the y-intercept, where it crosses this y-axis, right? Which is where that number right there came from, 0.4. But what does that mean? What would it mean if I said explain the point 0.4 in a sentence? What would that mean? In terms of number of players and cost, what does that point 0.4 mean? What's X? Number of players. How many players do you have in the point 0.4? 0.4, guys. 0. 0.4. This is X, this is Y. 0.4. So 0 players, what does that 4 mean? What's the Y variable? Oh, so what would a sentence be that describes 0.4? Do what? Not necessarily $4 per person. That would be a slope, because you're paying each. But $4 for what? It's a fee. It's a startup fee. $4 is 0 people. So no matter how many people play, you're paying $4. That's just to rent the whatever their little putt-putt ball in their club. That's their startup fee. We talked about that being a startup cost. And then if you look right here, they use that slope formula. You should know that one. Y2 minus Y1 over X2 minus X1 to be the slope formula. But why do we want to bother use this one? We could put, they picked 2 points. If we could put 2 and 4 in L1 and 8 and 12 in L2, pressing a couple buttons, and then do stat count 4, wouldn't it give us the same equation? Yeah, it would. So they're showing you without using a calculator how you could do all right, right here. We looked at tables last week. So you got or time. So I guess this is in days. So 0 days, 1 day, 2 days, 3 days, 4 days. And you got the number of bacteria. So it starts out at 1,000, and then 2,000, then 4,000, then 8,000, then 15,000. Now it says which type of function best models this set of data. So they want to know is if we graph this, is it going to be a linear, a straight line? Is it going to be a curve, a quadratic, or is it going to be an exponential? So if you had to guess, which one would those be? A line, a parabola, or an exponential, where it increases or decreases really fast? Which one? Linear, quadratic, or exponential? Sam, what do you think? You what? Linear. So Sam says a straight line. Anybody else? Guys, what's happening to these y values? They're increasing a whole lot. Remember when we looked at these tables, and I tried to put this up here to give you a hint, and we said the first difference when we subtract these numbers, 16 minus 8,000, that gives us 8,000. 8,000 minus 4,000, does that give us 8,000? No, so they did all these down here. Are those first differences the same? No, they're not the same number. And then, so it's not linear. Are the second differences the same? Are those three numbers the same? No, it's not a quadratic, so that means it's probably exponential or nothing. Well, does it increase really fast? Yeah, so it's an exponential. So remember, if we say 2,000 divided by 1,000, it gives us 2. 4,000 divided by 2,000, 2. 8 divided by 4,000, 2. 16 divided by 8,000, 2. So when you have the same rate, where did that 2 show up before? It showed up as a slope. You know, slope is a rate. So right here's where they're telling you this is an exponential function. You start out at 1,000 bacteria. Where did we start? 1,000 bacteria. What was that rate that it grew at? 2. And then T was your time. T is your X. So we did all that. Now, correlation coefficient, what variable is that in your calculator? R. That's your R. So they go through and they take this whole couple paragraphs to talk about it being between -1 and 1, whether it's a strong correlation or a weak negative correlation. You all know that already. I think the rest of it, we're not going to talk about residuals, so don't worry about that one. And I'm talking about, okay. All right, so let me go back up to, that was part of the lesson right there. That was half of it right there. Back to this one. Okay, now you know how to do this one too. Scatterplot. So you got a scatter plot, just a bunch of numbers. Well, think about this. Just look at the graph. High school GPA. Everybody know what GPA is? Your grade point average. It's like an average of all your grades. So it starts out as 2 and it goes to 4.5. So the higher your GPA, would it not make sense the higher your ACT score is? The better your grades, the higher the score. I mean, not necessarily all the time, but for the most part, that's usually the case. So the high school senior has a GPA of 3.0. Somebody right here. Which of the following is the best estimate of what his ACT score will be? So if he has a 3.0 right through here, what's the best estimate for what his score is going to be? 24. That's simple, 24, which is what they have right here. Alright, here's another one. Which of the following is a valid conclusion? So as the GPA increases, their score decreases? Not really. There's no relationship. What does that look like? What kind of relationship does that look like? It's a positive one, right? So if this one increases, this one should increase. So as the GPA of high school seniors decrease, their ACT scores remain the same? No. As the GPA of high school seniors increase, their scores increase. What's this right here? Alright, then we got some line graphs. So Jason, Steve, and Andrew made a line graph to show their cumulative number of miles they had run for 5 days. So they're adding them up. So the first day, day 0, they hadn't run anything. So on day 1, They had run this, day 2, just added up. This doesn't mean that they ran 2 miles that day or 6 miles that day. It means added up, that was their total for the week. So the first day, Stephen, this green person, it looks like he ran 3 miles on the first day, and he was a little bit over 6. So how many did he run the second day? He started 3 miles on the first day, and his total was 6 on the second day. How many did he run the second day? 3 more miles. Then on the third day, he's only at 8. So how many days did he run the third, or how many miles did he run the third day? 2 miles. So you got to understand what they're saying here. All right, so it says, at the end of which day had they run a cumulative total of 32 miles together. 32 miles together. Now, some of you are going to go over here and you're going to look for a 32. You see a 32 anywhere over there? No. What does cumulative mean? You know what cumulative means? It's adding everything up together. This is cumulative miles. So on day 1, just like what we were talking about, they had this many miles, and then day 2, so for the total, that week he had run that many. It would be like, Kyle, you went fishing yesterday. How many fish did you catch? 12, okay? So 12 bass, right? So how many fish did you catch today? 0. So what's your cumulative total? 12. So you're adding up how many you've done each day. All right, so we want to find where the 3 numbers adds up to be 32. These 3 dots. So I'm pretty sure it's not day 1. I don't think 3, 2, and 1 adds up to 32. Y'all? All right, so the best thing I'd probably start would be right here. What do you think? All right, so you've got your calculator. Help me out here. So that looks like 17, 15, and 12, maybe? 17, 15, and 12. What did you say, Lexi? All right, Lexi said 44. Did anybody else get that? Okay, so it's not day 5. All right, day 4. That looks like 8, 11, and 13. What is that one? 32. So what day did they run 32 cumulative total miles? Day 4. So it's not a hard question. I mean, was it hard to add 8, 11, and 13? No. I mean, you could have done that without a calculator. But you got to understand what the question's asking. So there it is, day 4. Now, we discussed histograms the other day. Remember, histograms are just bar graphs where the bars touch, and instead of just plain numbers, they have what across the bottom? What do we call these things? Starts with an I. N, T, intervals. Intervals, 0 to 2, 3 to 5. So it says how many people rented at least means 6 or more, right? So how many people rented at least 6 movies during the summer? So which bars would that include this bar? At least 6? No. Would it include this bar? At least 6? No. Would it include this one? Yep, this one? Yep, this one? Okay, so how many is in here? 7, 5, 2. How many is that? 14. Just 14 right there. You know what histograms and bar graphs are? I think that's it on this one. Okay, that's what we're going to do. Alright, we're going to go through some of these problems. These are the types of problems you'll see on this homework tonight. So think about this. Scatterplot High School is having a food drive. The graphs below show the weight of food collected each day. Alright, so we got all these. Here's day 1, 2, 3, 4, and here's the weight collected. Which of the graphs above show the best use of scale? The best use of scale. Well, look across the bottom. Are any of those the same? They're all the same, right? So there's nothing different there. Now, that goes 1,000 to 6,000, 100 to 600. Those are in ounces and pounds, that's grams, and in kilograms. Now just using common sense, which one, and this is how people do statistics to mislead you. R, I hear R, okay, maybe R. Talking about pounds, could be. Anybody else want to take a guess at why? Notice these bars look really small. They don't look like there's a whole lot of difference in those, does it? But this, it looks like there's a big difference from here to here, doesn't it? Or from here to here. Would that change your decision any? Well, what might we go with then if we don't want to go with R? We can still stick with R. What do you think? T? Okay. Well, T and S kind of look the same, don't they? But this one goes by 0 to 60, talking about kilograms. This one goes by grams. Which one do you think is better? T? So are we going with T? Okay, we'll go with T. Yay! T. Alright. So this one, he's testing the effect of hormones on pea plant growth. That's hard to say. Say that 3 times really quick. Pea plant growth, pea plant growth, pea plant growth. Everybody did it but me. For a scientist. Okay, so here he gave them a hormone, purple's hormone in all of them. That's the first thing you want to check. Purple's hormone, green's no hormone. You got days across the bottom, 15, 30, 45. So again, we got growth in meters, growth in centimeters, growth in yards. Everybody know what a pea plant is? I mean, even if you don't, do you think a plant is going to grow a yard? A yard is 3 feet, and you're going to measure, think about a garden. Anybody have a garden? You don't need to learn how to garden. But anyway, you're not going to measure a plant in yards. And that's in inches. So we're going meters, centimeters, inches. So I think we can say we're not going to go with yards, right? All right, so based on the other ones, which one does a better job representing things? Centimeters? Alright, so I hear S and R. This one's in inches, this one's in centimeters. They look about the same, don't they? What do you think? What are we going to go with?
Some people say like my score's like so many inches.
We're going to go with S?
Yeah.
Alright. Oh. So now what do you want to go with? R? Think about this. Centimeters, these kind of look the same, don't they? Just looking at the bar. The reason it's centimeters, always go with the smaller measurement. A centimeter is smaller than an inch. And so if you're trying to decide between two of them, go with the smaller measurement. Alright, next question. Alright, what's a valid conclusion based on the graph? So this says, it shows a relationship between a team's salary and their winning percentage. So, common sense, or you would think if you spend more money on your players in the NFL or NBA or maybe MLB, something like that, the more you spend, the higher quality of players you're going to get, probably? What do you think? Well, the better players you have, what would happen to your wins? It should go up. So as a team's salary increases, the winning percentage increases? I only hear Kyle. We need to look at the rest of them. There's no relationship between a salary and a percentage. As the salary increases, the percentage decreases. As the salary decreases, the percentage increases. That would be really nice. At least you pay somebody more to win, but that ain't the way it is. Think about this. This is a positive relationship, right? That means it's either going to be increase, or decrease, decrease. Those are the only two things that are going to make a positive. So increase, increase. It should be A. Yay! Alright. High school GPA. We're talking about GPA and college GPA. So if the higher your high school GPA, what do you think is going to happen to your college GPA? It should go increase and increase. And it says, what's the following best estimate of what her college GPA will be? So a high school student has a 2.5. So right here is 2.5. So if we follow that line to 2.5, well, we've got one here and we've got one here, right? So think about this. If we drew a line to try to connect most of these points, Where's that line gonna fall? We got two's down here. Would we guess two? Probably not, because two's right here. 3.5 is right here. So do you think that line's gonna go through that? Do you think it's gonna go through 2.75, which is right here? Or 2.25, which is right here? So what do we think? So you got 3.5, 2.75, 2.25, or 2. Right here, 2.75. Next question. Oh, here's another one. Which of these graphs shows the best use of scale? So this is how many minutes people spent taking pictures of things like an aquarium, a lion, a reptile, and a monkey. So we got seconds, hours, minutes, and minutes. Which one could you automatically think marked out? Seconds? Why seconds?
Because it's like real fast.
That's real fast.
And hours, usually gonna take like 100 hours.
Maybe. I don't know. They do have 2 minutes here. Would that sway you to think might be one of those? That's probably one of the things they're trying to do. But if you do that, hey, if you do that, let's look at these two. So this one goes 0 to 200, and this one goes 0 to 100. So remember I said, what did I say just a minute ago? If you're trying to decide between two of them, go with the one that has a smaller value. Well, this one's counting by 20, right? This one's counting by 10. So we gonna go with 2? Oh, don't let me sway you. Alright. Now again, high school GPAs and college GPAs. So what kind of correlation is this? Positive. As one goes up, the other goes up. See anything that's a positive? An increase and an increase? D. How easy was that one? All by knowing what correlation meant. Alright, here's another one. The height in inches. Now let's read this one. The graph below shows the result of an analysis of a group of 18 male students. The height is measured in inches, and self-esteem is measured by taking the average of the students' responses on a survey. Now, self-esteem, what does self-esteem mean? How do you feel about yourself? One's the lowest, 10 is the highest. So based on this graph, is that positive, negative, or no correlation? I feel like I'm yelling when that phone goes. It's a positive, you're right, because it's going up, right? So that means that as this one increases, what happens to this one? It increases. Do we see an increase? Please. Those are little things. Maybe those little things, and you'll get a lot of these questions right. Alright, space shuttle data. The potential for damage on a space shuttle. So this is saying as the temperature, now this is in degrees Celsius, what do we measure in? This is in degrees Celsius, which, don't look at it and say, oh, it's 2 degrees or 18 degrees or 19 degrees. This is Celsius, a different scale. So what happens here? What kind of correlation is that? It's a negative. Remember, you're sliding down the hill? So as the temperature increases, what happens to the damage index? It decreases. So based on this graph, what recommendations should be made for a shuttle flight if the temperature is forecast to be below 0 degrees Celsius? So if it is 0 degrees Celsius, remember, if we drew a line through here, it'll be somewhere up in here, isn't it? So would you want to be on that space shuttle? No, I wouldn't want to be in it, because at 0 degrees, the potential for damage is really high compared to down here. So what would you pick? B, the shuttle can fly if the temperature warms up to 2 degrees? Well, it might could fly, but that don't mean it's not going to blow up in the middle of the air. So we're going with C? Sure. Don't let me sway you. Alright. Tom and Holly are spending some time in Europe. getting back to which one shows how many days, which graph best shows. So we got days, months, minutes, and weeks.
Which way or is
Which one should we take away automatically?
or is
R because of the minutes. Days I'm not sure about on vacation. I don't know about y'all, but how long you go on vacation? You go for weeks, days, or months?
months is a long time.
Months is a long time to go on vacation, so I would probably kind of X that one out too. So I'd be looking at these two. So now, do the bars look about the same? Well, so here I told you. So the smaller one, which would be days, do you think F? I wanna go on vacation with y'all if y'all going for weeks. Y'all got a lot more money than I got to spend. Which graph shows how much Mark and Rox plan to spend each hour? So now they're on vacation, which one best shows how much to spend each hour? So this one's they're all in dollars, aren't they? So look down here, now they're in minutes, hours, and weeks. How much they're trying to spend. Oh, what does it say right here? They have a tight budget and trying to spend the same amount each day. Take out weeks? Which one's weeks? This one? Okay. It does. It says they have a tight budget and they're trying to spend the same amount each day.
I think it's R. I think it's R.
How many say T? How many say, what did y'all say, F or R?
This says EPA.
Oh, alright, so what are we gonna go with? Are we going with T? T?
Oh, R. It's R. I know it is.
R?
That is.
Okay, what's the difference between Q and S then? Guys, look right here. Time in minutes. 1 minute, 2 minutes, 3 minutes, 4 minutes. Look at the details. So what do you wanna go with? The little things, little things. Alright, so we're gonna skip this one. Let me go back. We didn't do the, oops. Go back again. Okay, down here at the bottom. Let's go, this one will be simple to do. Yeah. Yeah. Right, this one up. Okay, try this one. Oh, okay. Yep. Well, we do have some items, but we got some that they wanna get up to people the other day, so it's not working out too well.
I don't either.
Keep up the good work. Pay attention.
Alright, Scatterplot. The equation for the line of best fit is, alright, now remember, the one is in front of the X. No. Technically, yes, but right here, what's the number in front of the X, really? What's the number right in front of the X? What do we call this form? No. Y equals MS plus B. What's M? Slope. What's B? The y-intercept. Can we look at this and tell what the y-intercept is? Yeah, what does it look like? It's not by 10, so 30? 30? Okay. So the slope, remember, how do we find slope given a graph? We count up and over, right? Okay, so would you agree it goes through this point and it goes through this point? Okay, so now look, you're not going up 1, you're going up how much? No, from here to here, you're going up 10, 30 to 40, right? Now, how much are we counting over here? This is 100, right? But we're not going to 100, we're going to right here, so how much are each one of these worth? 25, 50, 75, 100, okay, so we go up 10 and over 25, 50, 75, right? So 10 divided by 75. Let's calculate. 10 divided by 75.
This one.
Make it a fraction, let me start the fraction. Do what? 2 over 15? That's what that? 2 over 15, did anybody else get that? Yay! Okay, we're not gonna worry about this one. This one here. Okay. Alright, what kind of graph is this? A line, a quadratic, or an exponential? Is that a line? Is that a parabola? Or is that an exponential?
Exponential.
Exponential. A parabola is a U.
Oh, part of it really.
What? Part of the U ain't U.
Halfway through.
Part of the U, because you have half a brain, don't mean part of the U.
I got what you said.
I know, U. The exponential function is
Yeah,
so
I
below
already got
to
that
be
one.
modeled with data. Alright. Based on that exponential model, there were blank cases reported on day 0. So really what they're asking is what's that y-intercept? What's that starting point? This is the equation. 53 is the starting point. And based on that model, the number of cases on day 14 and day 15 is right here, so I could get pretty close. So 15 is right here, 14 is probably somewhere through here. So what do you think? That's 200, that's 250, so what's that around?
You said one.
253? Okay, 253. There would be 800, now this is a trick, there'd be 850 cases, you see 850 anywhere on there? We're looking on the wrong side there, right? We need to be looking over here. 850 cases reported by day, so 850 is right here. So between 20 and 25.
I told you guys it wasn't 250.
I didn't hear you say anything.
You said it,
Oh.
Kyle.
Alright, we're not gonna worry about this one either. I'm just gonna guess and. Oh, come on. Oh, I guess I'll.
You don't want to look at it.
No, they did guess it. Alright, which of the following is the equation of the line of best fit? And we can figure this out. We need two things, right? The what and the what?
Why?
What did we just find 2 questions ago? The slope and the y-intercept. What is that red line across the y-axis? What? Negative 30. This one has a negative 30. That one and that one, right? So the only difference is a 6th slope or a 3/5 slope. So let's say, okay, here's a point. Would y'all agree that's a point?
Yeah.
And that's a point. Alright, but we gotta be careful because this is not up 1, 2, 3. How many is that? That's 10, 20, 30. These are counting by 1, so it's 30 over 5.
That's why it's
30 over 5. 30 divided by 5. 6.
Well, I think you should just like this.
I did not take it. Okay. Okay, we're not gonna do the residuals, the way y'all think, let's guess. D? Alright, we're gonna guess on this one, what do you think?
I say C.
What y'all say?
C.
A.
Yes, what do you think, AJ? C? Oh.
I bet it's B. B.
B?
Yeah, go with B. I bet it's not.
What's your C down, Kyle? I don't know, this one we can do. What are the two things we need to write the equation? Slope and y-intercept. Yeah, but you didn't say y-intercept.
I said
You said
Y.
y-axis.
No, I just said Y.
Okay, well, what's the y-intercept? 5. That help us out any?
Yeah.
They're all 5. Alright,
I
so
bet you it's either A.
let's take some points. Alright, here's a point and here's a point. So we use this one and this one. So we're counting up. So from here to here. Now we're not counting up by 5. We're counting by 2.5. So from 5 to 10 is 5, right? So that's 2.5. So 2.5, 5, 7.5 divided by what? What am I pointing at right there? Which is what? In between 2 and 3. 2.5. Lord have mercy. So we went up 7.5 divided by 2.5. 7.5 divided by 2.5. What is it? Is it 3? Yay! Alright, we're gonna guess. Alright, we're guessing again.
The first one.
Not a good fit or a good fit?
Not a good fit.
Not. Random or non-random?
Non-random.
Sam says that crap's random. I think that's the end of it. Oh, I got another one. Alright, we're guessing.
Hold on. C. A.
I think we.
No, A.
KJ, you're our deciding factor again. Which one? D or A? D? Oh, okay. Alright, you got your Chromebook. Now you, like I said, you're gonna have at least 30 minutes. You got almost 40 minutes. So over 30 minutes to work on this. You got 2 things, okay? 30 minutes to get as much as you can done. Don't rush. Don't rush. If you feel like you got a question, don't just guess at it. Now let me just go ahead and show you exactly, when I say I know what you're doing, let me show you where I'm going to, and you can be my witnesses. Here's 4th block. And if I go to the assignment, Scatterplots and interpreting graphs, well, I can see who's done some.
They did nothing.
Nobody's done anything yet. You gotta get started, dude.